Okay. Yeah. Thank you all for joining. With Kiping and I'm myself co-chairing the ACE working group. We already in the beginning we scheduled a couple of conference calls to talk a little bit about state-of-the-art and existing technologies, and this is one of those talks. And this time we talk about lightweight M2M, which is standardization work done at OMA and the Open Mobile Alliance to deal with device management. And Simon and I will lead you through the talk. We will switch back and forth to provide you the best possible experience, so to speak. I have a couple of persons with me in the room in addition to the guys you see on WebEx. There's I have Phil Hunt, I have John Bradley, Brian Campbell, Mike Jones, obviously myself. Suresh, can you go on mute? Tony Nadlin, Daniel Fett, and Guido Schmidt. Suresh, go on mute. Suresh. Okay, now he went on mute. Okay, so I will start. So I will focus on the security-related parts and let Simon take care of the rest. And here's the agenda of what I would like to talk about. First, start off with the lightweight device management and why it's actually there. Talk a little bit about the standards work and what's there in this specific specification. Followed by what the OMA calls the bootstrapping interface, which is a security sort of mechanism for distributing keys and access control policies. Speak a little bit about the object model, which is then also used for the access control mechanism. And in the end, we'll talk about how to integrate lightweight M2M into applications and show a couple of example flows. And by the way, if you have questions, just unmute yourself and go ahead and interrupt us at any time, please. Okay. Good. So why do we have this device management solution, and why has the OMA been working on this? And there's a certain historical background to this. Namely, in traditional device management, long time ago, which was used on smartphones, OMA has worked on a protocol solution which has been used by cellular phones, and so it was at that time it was one of the first standards that the OMA has successfully deployed and used throughout the mobile handset sector. Of course, things have changed. Meanwhile, the original device management was more heavyweight and had a lot of additional functionality, which wasn't necessarily needed by IoT devices. And there's also other work, concurrent activities that happen, like the work on TR69 or the IEEE work on 802.1 AR, which happened in different organizations. Okay. Gabriel, could you go on mute? Please go on mute if or everyone go on mute if you don't talk, so we don't hear the background noise or an echo. Oops. Thanks. Okay. So that was there many years ago already, and so that inspired the OMA, the Open Mobile Alliance, to work on an IoT solution also for the device management solution, and with the goal to apply also to various radio technologies, so just focus on IP to have sort of an extensible object model, and what that is, Simon will explain you in a second or in a few minutes. And have both sort of management of the security credentials as well as the application data at the same time. including things that are often needed, like software updates and device reconfiguration. We don't go into a lot of details on how the software update works, but it's interesting and important for IoT security, but not necessarily something that we look into in the ACE working group. And what I think is best with the work is it reuses a lot of IETF specifications, as you will also see later. There are various different features, so if there are more features beyond the security part, so quickly glance over those. So I will talk about the first item, this bootstrapping, which talks about this key management and the access control aspects. It also has along with the key management, has a service provisioning component, which I will explain a little bit more. But then there are lots of other features that are commonly used in context of device management, which had been sort of carried over from the prior work on their device management for mobile phones, which include all this reporting and sending information about faults and do configuration management, application-specific configuration, and so on. And also the software update, firmware update mechanism that I mentioned earlier already, which is important. From an architecture point of view, it's a client and server model. So you have the IoT devices. So if you look at the picture on the left-hand side, there are IoT devices which have a lightweight M2M client running on them and supporting different objects. And then on the other side, on the server side, which may be sitting somewhere in the cloud, or it may be sitting on a gateway in your home or somewhere else, doesn't really matter. And all the protocol standardizes the communication between those two entities, which is illustrated here. And the stack, as shown, includes the CoAP protocol, so it uses CoAP instead of HTTP. It also uses DTLS along with CoAP, obviously because CoAP has this as a sort of mandatory security mechanism, and it can run over, and as DTLS runs over UDP, it can do that, or alternatively over SMS. It also, I noticed this in the text, it not only uses the CoAP protocol, but it also various sort of specifications that were developed in the core working group, such as the resource directory, and also other related specifications there. So that's for the architecture. But on the topmost part of the diagram, what you see is these so-called M2M applications. So you could see the lightweight M2M service as sort of a middleware that then interacts with some applications, and those applications may be anything, like maybe other web servers, or it may be smartphone apps, or it may be who knows what. And there's the regular REST APIs are used for interacting with the lightweight M2M server, typically over HTTPS. We're going to talk about that also a little bit later on, describing the bigger picture on how lightweight fits into the rest of the application ecosystem. Okay. Now getting a little closer to the security aspects and the standardized functionality. I mentioned this bootstrapping interface, and it's a weird term. A lot of confusion about this, also in the IETF, but essentially it's a key distribution mechanism, and it's also used to distribute access control lists. And it uses the protocol uses a CoAP, obviously, to exchange messages, and there are two flavors to initiate that exchange. Either it's the client initiated, which is sort of the regular approach. A client wakes up, for its IoT device wakes up and talks to the server side, or it's in some cases it may be acceptable to also have the server initiate the whole exchange, which is typically, like if you think of an ordinary IP network, it's always a little difficult to have the server initiate the communication to begin with. And then there are a couple of sort of management interfaces that deal with the registration of various objects. And Simon is going to talk about those. But in a nutshell, you have the resource directory functionality where the client registers to the server and indicates on what resources it has and updates those resources. And again, this uses co-op. And then there's also what additional specification that is being used here is co-op observe to actually have a sort of a publish subscribe mechanism, which is shown at the bottom of this figure. Again, some work from the IETF core working group. So it's useful for reporting if the server subscribes to certain events, specifically false, in other problematic cases, then it gets notifications or any value changes in objects. Okay, talking a little bit more about the security-related aspects, which I think is most relevant for the work we do in the ACE working group. This is sort of a simplified flavor of the architecture as I see it. It has there's the KDC, which of course in the OMA specification has a different name, and it pushes keys to the clients and the servers. And those keys are then subsequently used for letting the client and the server talk to each other using a DTLS secured communication channel. So this is sort of like the most simplistic way of seeing it. And in the next slide, I will provide you more details and also the OMA related terminology. So if you go and look at the specification, you actually find your way around it. So in the OMA terminology, there is, as said on the IoT device side, there's this lightweight M2M client application or code, and it can either initiate the whole exchange or have the exchange initiated by the server, which is what these two message flows are supposed to indicate. But then on the server side, there are servers can play two different roles, and one is the role that is being played during this bootstrapping process by a server is what is called the bootstrap server. So quite obvious, but this is sort of what I labeled as the key distribution center in the previous slide. And so the exchange is rather simple. What it does is, in an abstract, the client asks the bootstrap server to initiate the bootstrapping, and it sends what is called the endpoint name and runs this over DTLS. Of course, you want to secure the distribution of keys. And then it gets, as a response, what is called server objects, or a couple of objects back. And these objects are defined in the specifications and include keying material. So on a high level, pretty simplistic model. But of course, there are some details. The details are in exactly these objects, and I'm trying to go in a step-by-step fashion to explain more of those details. So obviously there are more details. So so this is a variation of what I've shown previously. I showed you the lightweight M2M client at the bottom, and then there was the bootstrap server. And when it gets these keys in these objects, then obviously it uses those objects with something, and it uses those with different so-called lightweight M2M servers. For example, to do the other operations such as registering resources. And here, so this is then the diagram. So think of it as, if you compare this to to a model like, for example, Kerberos, and you similarly have the client talking to the Bootstrap server and sending this Bootstrap request over DTLS. Everything here is over DTLS, so it's not going to repeat that every time. But it needs to authenticate itself to the Bootstrap server as the client, so it needs to have some credential to start with. And this is a fairly common assumption with many of the IoT sort of security work. So you have to have something to start with. And in this case, in many cases, it's assumed to be a manufacturer-provided key, which I try to show with this box inside the client IoT device. And so when the Bootstrap server sort of recognizes that device, then it generates this response. And here I described it differently. Instead of calling it object, one way to call it, these objects are, it provides the key that is subsequently going to use with this lightweight M2M server, and also, of course, with information about which server it has to talk to. So because initially it doesn't know anything other than the information of which Bootstrap server it is configured to talk to and what the manufacturer provided key is. It might be in hardware, it might be in a SIM, it might be, who knows how it gets there. It's not further specified. And then when the device, the IoT device then talks to the lightweight M2M server, it makes the request, uses that key with DTLS, and then does whatever it has to do, and then it gets the request granted or not, which is then obviously subject of the application logic, depending on what it's supposed to do. The key distribution that may need to happen between the Bootstrap server and the lightweight M2M server is sort of outside the scope of the lightweight M2M specification. So there's some, for example, in some deployments, there's just sort of some APIs that are used between those servers. So you can most likely deployment is just to have it between some backend infrastructure, exchanging some data or accessing a shared database. So does that make sense so far? I hope it does. Okay.
Hannes, this is Brian. The one thing I don't get in this discussion is how do you deal with identity? How does the key server, the Bootstrap server, know to whom it's talking?
Yeah. So good question, Brian. Thanks. So it depends a little bit on the credential type being used, and I think it's actually here. The lightweight specification supports different credential types, namely pre-shared secrets, raw public keys, and certificates. And jumping back to this picture, the answer is a little bit different depending on which credential you use. So let's assume for the moment we are talking about shared secret. So imagine there's some shared secret provisioned here on the IoT device together with some identifier. And when that client then talks to the Bootstrap server and the client uses this shared secret in transport layer security, then in order for the client to actually recognize and authorize that client to send him the necessary configuration information, it needs to have some database somewhere where someone told him that this client is provisioned with those type of configuration information. So it may, of course, there will be more than just the keys. There will be information about which server to talk to and so on, or also what reporting the client should do, what data it should send where, and so on. So that information has to be provisioned into the Bootstrap server, and so this has to happen outside the protocol. So if you think about, like, for example, in an industrial IoT use case, then most likely that provisioning step will happen when you buy when an enterprise buys these devices, whatever those are, and provisions their backend databases to make use of them. Does that make sense what I said? Does that answer your question?
Well, only for pre-shared keys. Is that the only model it supports?
No. It supports also raw public keys and certificates. I'm actually going to explain a little bit more, drill further down into those details because I thought that they could be relevant for the ACE group on how that looks like. But yeah, so there's more than that.
So when this says credential provisioning, you don't mean key distribution center provisioning to client. You mean prior to contacting the key distribution server, the Bootstrap server, you do this provisioning so that you can securely connect. Well, so that the Bootstrap server knows who you are. That's what you mean by provisioning in this sentence.
Another good question. Actually, it means both. So the specification is a little flexible on that. It supports the keys that are already pre-provisioned to the IoT device, to the Lightweight M2M client, already up front. It can support these type of credentials when it authenticates itself to the Bootstrap server. But the Bootstrap server can then also use these 3 different credentials for provisioning with subsequent servers. So you can actually, as I described here, you can actually mix and match. So, for example, you could have in some deployment scenarios, you could start off with let's say a certificate, manufacturer-provided certificate, and start with that one to authenticate to the Bootstrap server. But then, for whatever use case it may be needed to actually use symmetric keys, and then the Bootstrap server would send the Lightweight M2M client the symmetric keys for use with specific servers. It depends a little bit on what the use case is.
I think I understand. Thank you.
Cool. Okay.
Good. I have a question just for clarification. This is Ludwig. Basically, the device identifier is some fingerprint of the key it has gotten from the manufacturer then, or is that something else?
The Lightweight M2M specification doesn't go into that detail. It says you are sending the request with an endpoint name, and what exactly that endpoint name is up to you, or up to the device. So this would be the endpoint name that is used in co-op with a request at the co-op level. Of course, the identifier that's being used inside TLS depends on the specific credential type. So, for example, with a pre-shared secret, it will be the ID, the BSK ID, and the corresponding secret. And with a certificate, it will obviously be whatever is in the certificate. Does that make sense?
Yes, thank you.
Good. Okay. So, and I tried to describe this in a little more detail than what Brian just asked me a minute ago. It's again in an abstract form rather than literally describing the object as they are encoded. But if you have the, I try to reiterate over that again. So what this does is you need to have certain information pre-provisioned, which is sort of this purple box. And then there's dynamically distributed information, which is the green box. And then there are various places in which you actually demonstrate a possession of your a secret key or private key, depending on the mechanism. So, for example, when the Lightweight M2M client uses the pre-shared key mode, it has the following information pre-provisioned during manufacturing or otherwise provisioned using, for example, a commissioning application. it has to have its identity, this identifier for the BSK identifier. It has the corresponding secret key, and it needs to know which Bootstrap server it has to talk to, because otherwise the whole thing wouldn't work. And then it runs the DTLS protocol with that Bootstrap server, and here I also described a little bit in more detail on what the Bootstrap server actually then has. Of course, it has the same secret provisioned in its database as well. So this is obviously each credential type has pros and cons. So in this case, you obviously need to maintain a database with shared secrets. So this is like, if you think of the SIM card world, this is a very obvious model, because the SIM cards with the AKA authentication rely on a shared secret. And then in this case, I not only assume that the Lightweight M2M client uses pre-shared secret authentication to authenticate to the server, but it also then gets another pair of shared secrets provisioned. These are the green boxes, so it can then securely talk to this Lightweight M2M server. And so it gets to know which server it has to talk to. This is the first item. It also gets to know what shared secret it then has to use at the DTLS exchange. So this is what comes in these objects. And then it does the dance again with just regular DTLS, as shown earlier. And of course, the Lightweight M2M server somehow needs to get access to these credentials, because these dynamically generated credentials, pre-shared secret credentials, otherwise it wouldn't be able to authenticate neither the client nor himself to the client. And to see a little bit the comparison to a different type of mode, which I didn't explain to Brian previously, let me focus on the certificate mode as an alternative. In the certificate mode, you have a trust anchor store. The trust anchor store on the client indicates, or allows, it may have a single certificate, not like in the web PKI model where you have hundreds of trust anchors. But here you may have just a single certificate that allows the client to authenticate the Bootstrap server. It may even be the entity certificate if you really want to sort of nail it down to one specific server only. Or it could be a CA certificate. It doesn't matter. Depends on the deployment. And in this case, this is the regular, it would be the regular DTLS mutual authentication run that is executed between the client and the Bootstrap server. And it would just use, like in all of those mutual authentication cases, it would then use, it would have the client would have a certificate and the corresponding secret key, and it would use that to authenticate itself to the Bootstrap server. And of course, the Bootstrap server would also have a certificate with a corresponding secret key. And once it successfully did that, it again gets information provision. So in this case, I also assume, like in the earlier one, it just provisions certificates. So the Bootstrap server would either generate these certificates on the corresponding private keys on the fly, or it would have them pre-calculated. But regardless on the method, it sends the shared secret, or the private key, which is called SK here, and the certificate to the Lightweight M2M client. In those newly generated certificates are meant for use with the Lightweight M2M server subsequently, which is then the other request. So Brian, that's sort of like in comparison the certificate mode And obviously, you need to store different information, the different requirements on hardware and storage, of course, and of course on the actual over-the-wire transmission when you use certificates compared to shared systems.
Yeah, I got it, and you explained it, and I'm following all along. So you're doing well.
Thanks, Brian. Okay, and finishing this off, there are different types of objects being defined in the Lightweight M2M specification, which I didn't list by name in the previous diagrams, but here they are. So they are indicating the security mode, whether it's a certificate, what the identifier is that is being used, the different keys, and of course the URIs that are being used to access the other servers. Fairly obvious object if you follow along the protocol messages. Simon, I'm handing over to you to explain a little bit more about the object model, going more into the details on how these objects look like.
Sounds good. So good morning, good afternoon, good evening. So I'll go over a little bit the object model and what it looks like when you start interacting with a Lightweight M2M client as a Lightweight M2M server and vice versa. So if you can go to the next slide. So Lightweight M2M, how they did it, they made it fairly easy to navigate through the resources that your device might expose. So the way that they do it is that they have the concept of basically three levels to access their resources. So the Lightweight M2M client as one or more object instance. Well, let's take a step back first. I'll start by just explaining what the three layers are. So the way that they separate them is you first have an object ID, which defines sort of like a category within your device. Then you have an object instance. So it defines basically a specific instance of that object, which you can have multiple of. And then within that object instance, you have a resource ID. The resource ID is your last gate to the actual value you're trying to get. It defines one specific thing within your device. So the Lightweight M2M client can have more than one instance. And as I said earlier, the resources are sort of like a collection within an object. So anything that you do in terms of trying to get value out of your device is done on that resources. And this is where you can either read the value, write something within that resource, or it could be just a resource that is executable if you want to actuate or something like that. The resources can also be a collection. So that helps, let's say that you want to expose to the server the different types of network interface that you have. So you might want to put all of those within one resource ID, but it'll still return a collection of all, let's say, those network instances that you have. And then there is also the ACL, which we'll cover a little bit later, but it's basically an access control layer that you can bind within your object. And then it also gives, well, as it explicitly says, access control on that specific object. So if we look at the diagram on the top right corner, there's two different examples of what can happen on the Lightweight M2M client. So in this case, for instance, you have an object 0. So object 0 has 4 resources, and resource 4 in this case is a collection of multiple resources. So let's say, for instance, the network interface example I gave. And then object 1 has also 4 resources in this case, but the client actually has multiple instances of that one object. And this can become very useful if you have something that can be changed. The other use is that you can also create and delete instances on your object. So if it's something that the server wants to sort of like store information on the client itself, you can send a create or a delete on a specific object to create the instance. And basically, interaction with those resources are very simple. So they're all URIs. So anything that you would do to URI applies here as well. The object and resource identifier, are 16-bit integers. The instance are 8-bit integers. So when you start building or gathering all the resources your device have, you can easily class them into those three specific layers, and it gives a really nice structure that can be easily reusable across the border. Next slide. Excellent. So the Lightweight M2M or OMA as specified mandatory objects. So there's 7 objects right now that are specified by the standard that cannot be changed, and the IDs are the same. So in the ID column, that's basically the object ID that I talked about a little bit earlier. So you have object 0, which is Lightweight M2M security. You have object 1, Lightweight M2M server. Then you have your access control object, which would be ID 2. Device object, which is anything specific to your device. So, manufacturer, model ID, things like that. You have connectivity and monitoring, which is 4. Firmware, which is 5. Inside the firmware object, this is where Hannes briefly mentioned earlier, all the logic when we talk about updating the firmware, what kind of firmware do you have, where do you get the firmware. So all the resources inside that object relate to that specific function. 6 is location, and 7 is connectivity statistics. So those objects are all predefined within the spec, and some of them can have multiple instances, some of them cannot. So for instance, if you issue a create on the object device, that will return you an error because that device cannot have multiple instances for obvious reasons. So these objects are mandatory, or some of them are mandatory when implementing OMA. And the fact that some are mandatory as well help, let's say, agnosticize the interaction with the specific device. So next slide. So here's a object example. So if we take, for instance, object 6, OMA describes the object in this fashion. And if you went out and designed your own objects for your own specific needs, this is something you would do something like that to sort of fully expose what the object can do. So you have, your resource name, the resource ID in this case, the access type. So do you want it to be a readable, writable, executable, or multiple of those choice for that specific resource? Can the resource be of multiple instance? So is it a collection? Then what type is that resources? So decimal, string, opaque, date. Well, I'm sorry, time. And then you can specify a range as well. If you want to add boundary to that specific resource, you can then specify the units. And then, well, the description obviously is mostly for the reader, but it's always nice to have as well. So next slide.
Simon, I have a question.
Yes.
So resources have an instance, but then you also said objects have an instance. I'm a bit confused.
Yeah. I agree with you. The term is a little bit overloaded, the term instance in this case, because the object instance is very well defined within that tree. So if we take a concrete example, in this case we have object 6. So it's 6, let's say it would be instance 0, and then resource ID 1, which is longitude. If we took an object that had multiple resource instances, let's say, I think if I'm not mistaken, connectivity is 4, then you would have instance 0 for the object. You would have resource ID 3, which I believe are the network interface. The path stops there. The only difference is when we say resource instances, that when you query that specific resource, you're going to get back a collection instead of a single value. So I don't know if that answers your question.
So both resource and objects have instances.
Yes. Again, personally I feel like the word instance is overloaded in this case because they do not necessarily have the same meaning. Because you can create an object instance, but a resource instance is something that the device will have. So and you can't say I want to have the resource instance 5 because you're just going to get that resource ID and you're going to get the full list of it. You can't narrow it down to a resource instance in your path.
Okay, got it.
So next slide, if there's no more question. The way that OMA did in terms of creating, because obviously once you start implementing Lightweight M2M, those, for instance, 7 objects that they've created will probably fit some of your need, but not all of them, because any specific business logic will require you to create your own object. So it's fairly straightforward to define new objects. OMA as a naming authority, OMNA. So basically, once you create your objects, you go to the OMNA, and then there's a specific form that you fill out. So you choose your object ID, and then you fill out a form that resembles a little bit like the diagram we saw earlier, where they're going to ask you the specific features of that object, and then you submit it, and that's pretty much it in terms of submitting a new object. There's also, I can briefly touch on the IPSO Alliance, which is something that is trying to basically create a set of generic objects that can be easily reusable. So instead of having, let's say, for instance, 700 registration for a thermometer out there, or something that might be reused, then in this particular case, IPSO is trying to find, right now in our industry, what are the common actuator and sensors that people are using, and they're creating a set of generic objects for them. So it's always good to go have a look at what they're doing, because it might actually save you the burden of creating your own object, and at the end of the day, sort of, creating duplication in the world of Lightweight M2M objects. So next slide. So for access control, I'm going to give the control back to Hannes. He will guide you through the access control model.
Thanks, Simon. I also wanted to mention that there's currently a call for position papers from the IEB on a workshop on semantic interoperability, which specifically touches on the aspect of how object models look like, how metadata is exposed, on how to deal with extensibility, how the whole registration processes work to sort of harmonize the work on these different information and data models. So have a look at the IEB webpage and look at the call for position papers on that topic. because obviously the OMA approach is only one possible approach, and there are other ideas floating around. But anyway, so Simon mentioned previously that the objects also come along with access control lists. And if you spend the time and look at the OMA specification, which we have a pointer to the downloadable spec a little later in the slide deck, then you will see that there's also an example included in the appendix, and which sort of illustrates the approach of how different devices can, or specifically the Bootstrap server can decide about who is allowed to access data. Because ideally we want to be in a world where not everyone can access any data that is being exposed by objects, but you rather want to decide on make sort of certain differentiations on who can access or also subscribe to data items. And this is what the access control policies do. And here I try to provide an example based on a more complicated example, I would say, based on luminaires and light switches. So in this case, you have on the right-hand side, upper right-hand side, you have a luminaire acting as a lightweight M2M client, and you have a light switch, and the light switch in the middle, and a Bootstrap server that is responsible for distributing these access control policies and providing read-write access in this specific case. And if you recall that Simon mentioned that certain read-write execute commands are being able to be submitted to certain endpoints and encoded in this sort of unique style. What happens here is, in this specific case, the Bootstrap server, for example, here says that the lightweight M2M client as a luminaire is allowed a specific resource, for example, to a resource that allows you to switch the light on and off, gets an access control that says a specific UI as a server 1, which happens to be the light switch in our example, has read-write access to a certain resource. So I didn't include the resource, but just the access control. So what that specific light switch would then do is to register to that client and then provide the capability to, or would be given the capability to turn the light on and off. And similarly, in a more complicated setup, there may be actually multiple servers controlling different applications, and the Bootstrap server would provision them independently. So here in this scenario, we have not just one lightweight client sitting in luminaire, but actually also in the light switch, because it interacts with some other server for whatever purpose. So there's the possibility to also similar to Bluetooth Smart, where you can sort of make access control decisions, the resources along with access control values, but in this case it's more flexible. A little bit of discussion, because obviously there's a lot of different features you can provide, and where these access control lists work particularly well is if you have upfront knowledge on who these servers and clients will interact with. There's also a real-time provisioning capability, so it doesn't need to be, everything needs to be happen up front at the time when the interaction with the provisioning works, but it's actually a whole, call it a lifecycle management, where things may change with the different IoT devices, whether it's a firmware update and so on, or new security keys need to be provisioned. In the same fashion, new access control policies may be pushed down. But it assumes that the Bootstrap server is actually able to contact the devices, or that the devices regularly or periodically contact the server. I think there's this caveat, so it doesn't come out of thin air. It has to be provisioned somehow. And what is also sometimes confusing is in the terms of roles is while you have this lightweight M2M client, the relationship with what it acts as a co-op client is sometimes using. When reading specifications or also the description, bear that in mind, because the client may be the Lightweight co-op client during the registration step, but it may actually be a server later on when it waits for incoming requests, because it actually has the resources and offers them to some other nodes and sort of switch. So it still remains to be a Lightweight M2M client, but it's then different. And also, some nodes may have sort of client and server roles at the same time, depending on what they actually do in that. And you also saw in the previous interaction. So don't get too religious about the client server roles because they may change. Simon.
Yeah. So now that we've seen things a little bit more granular, if we take a step back and look more at interaction between your ecosystem, if you're using Lightweight M2M. So usually a device, after doing the bootstrapping, will go in and will register to the Lightweight M2M server. By registering, it's going to expose the resources that that server can interact with. So it's going to send up, first of all, its endpoint name, and it's also going to send up the resources that it has. And if you're familiar with CoAP, I mean, if you look at the payload of that message, you'll definitely be in known territories. So once this is registered, I mean, any web application or web server that sits on top of your Lightweight M2M server can then start querying or asking your Lightweight M2M server, who is talking to you? What are the resources of those devices? And then, so if we go to the next slide, once we know how to interact with the device, it becomes very easy for a web server to just issue a basic REST call to the Lightweight M2M server, where then that Lightweight M2M server will then just do the co-op call. In this case, we'll do a get, which translates as a read in Lightweight M2M. And then the server will just reply with the specific queried value. In this case, would be resource 5700 from object 3303. So yep, it would just get the device. The server will then reply. Again, the underlying application protocol is CoAP. So very straightforward in this sense. So if we go to the next slide. The other thing that we're going to touch a little bit more a little later on is that there's also the observe option in CoAP is also heavily reused in Lightweight M2M. So in this case, let's say that the previous slide was not just a get, but a get with the option of observing. Then in this case, the device would then start notifying with the specific rule, depending on a write attribute command that we'll talk also a little bit later on. And then we'll just notify the value following those specific rules to the Lightweight M server, which can then be sent back to the web server app. So next slide. Lightweight M2M also support sleeping endpoints. So when you register, when the client registers to the Lightweight M2M server, it can say that it will operate in queue mode. What this means is that the server knows that the client will go offline sporadically. So in this case, the client would come up, it would register itself, specify that it's in queue mode, and then the server would then reply with the proper response. The server will then go offline. The client will then go offline, and the server knows that. So it will wait in queue operation until that client comes back, update its registration, and then the server knows, okay, my client is online. I have these queued operation I need to perform. So in the particular diagram here, for instance, there was two queued operation, a put and a get. So at this point, the server will interact with the client, and then the client may go offline after that for undetermined specific amount of time. And then the server knows that it needs to now queue operation until the next time the client comes back and update its registration. So if we can go to the next slide. So as I mentioned earlier, the observe mechanism in co-op are also heavily used in Lightweight M2M. So in Lightweight M2M, you can specify, you can trigger observation on resources, but they also have an extra command called write attributes that can be done. So write attributes puts, let's say, boundaries or filters on the device and say, well, I want you to notify me, but here are a specific guideline as to when you may notify me. So you can specify a pmin, pmax, which deal with periods of times. You can specify a lower than or greater than. If you want to say, well, this is my lower threshold, this is my higher threshold, only notify me when you hit those thresholds. And then there's also, you can specify step. So you only want to be aware of the notification only if the minimum delta change happens. So next slide. You can also in Lightweight M2M do bulk read. This is basically where you can say, well, I want to have all these information in one specific chunk. And so in this case, you would return a TLV or JSON. TLV is specified in the Lightweight M2M spec as to how you construct your TLV message. CBOR needs to be added to the spec, and I know there's talk about it, but obviously this is something that needs to happen. And it also supports linked objects. Next slide. And Hannes, also feel free to jump in if you feel I missed any information. So the Lightweight M2M also uses the resource directory for resource links. So this is an effort that was made in core. So the links are uploaded during registration to inform the Lightweight M2M server about the resources on the endpoints. So you specify your resource type, your content type, and for instance, if it is observable. The resource link is reused in Lightweight M2M. So the links are discovered when doing a get with the content type link format. And then if you want JSON, then you need to specify that specific content type. So next slide. So we have a little bit of example flow.
Simon,
yep.
I was just wondering whether we should, we are already past the hour. We should probably skip over the flows and then jump to the end, so to give folks a little bit of time to ask questions. Would that make sense to you?
Yeah, absolutely. And with the flows, we've covered them, so they're just sort of a recap of the interaction between the client and the server. So yeah, that's a good idea.
So you would have to look at them yourself, but I think they should be easy to understand given what Simon has said already. To summarize here, like you've seen that the lightweight M2M specification reuses a lot of the work done in the IETF, and it's also available. The lightweight M2M specification is also available for download, and you can find the link in the slide deck if you hit on this here link. There are also implementations available, both open source and also products. And one of them is something, Simon, you may want to say a few words about. It's Leshan. Simon.
Yeah, absolutely. Leshan is an open source project under the Eclipse Foundation. So Leshan is fully open source. It contains both server and client. And so if you go on GitHub and you go at the Eclipse Foundation repository and you go to Leshan, they explain a little bit how things work. It's very modular as well. And they also host a test server where if you have a client and you want to connect to a server just to see, how your resources are exposed and if things are working, they also host one that can be used. So it's a strong project that has quite a bit of following, and it's always very well maintained as well.
Yeah, and the reason why I mentioned it here as well is when I taught a lecture at the university on IoT, I used Leshan as a sort of an example platform that students found easy to use. So it's not that complicated to set up as well. So progress, the lightweight M2M specification has been out there for some time already, and there were several bug tests that took place in issue tracker on GitHub. So you can look at the open issue list, and some of these issues are currently being worked on and resolved in a bug fix release. And there's also next year there will be version 1.1 specification being worked on and then published later on, which improves the alignment between the lightweight M2M specification and ongoing IETF work. As things are advancing in the IETF, there's the desire to make use of those results. So that's everything we had. I hope it was helpful for you to actually then find your way through the specification and gives you a sort of a sneak preview. Are there any questions?
Honestly, I have a couple of questions. You hear me?
Sure, go ahead, Gabriel.
Okay. Yeah, one question is about the transport. I know, well, COAP is the assumption there. Has there been any requests or interest in HTTP? And if so, do you see that as a major piece of work, or would everything pretty much translate into HTTP land? And the other question was pairing the data model with OMA DM, the old traditional OMA DM. Is there any difference in the data model, in the object model?
Okay, let me respond to the first question, and maybe Simon knows how to answer the second. So on the transports, yes, there has been interest to use different type of transports besides co-op over UDP. So for example, there was interest expressed in prior IETF meetings to use co-op over TCP, which Simon, I, and Carsten Bormann had been working, and also HTTP and HTTP2 had been raised as potential new items. So hasn't been worked on yet, but it's on the agenda. And I don't think it would be a major piece of work, particularly because most of the definitions, like for example the object model, just uses regular REST API. So it's as long as you can actually, if you have REST-based design. Simon, do you have an answer to the second question?
I don't have a very good one. From what I know, I don't think that there's any work in the mapping. I know that there are some paradigms that have sort of been ported from DM into Lightweight M2M, but I am not aware of any effort into linking the two. But to be fully honest, I can be wrong on that.
Okay. Thanks, and thanks a lot for the summary, the tutorial you just gave. Very informative. Thanks.
Well, we can find out. So neither Simon nor I have actually worked on the initial Lightweight M2M specification, so that's why we are not able to tell you about those design decisions. So we are, in some sense, we are late at the party, but still thought it worthwhile to look at the specification. Any other questions?
Hi, Hannes. This is Alper. Is there any information on the deployment of Lightweight M2M?
Well, I can only tell you about our deployment, but I don't know. I haven't done any survey on what others are doing, what other companies are doing. So at least for Simon, who works for Zebra, and myself working for ARM, so we have products and use that stuff. In fact, I have pointer use if you want to use this sort of development. You can basically look at that slide, click on the links, and use it with your IoT device, or whatever. It doesn't actually need to be an IoT device because there's also a client and a free web service and so on. But yeah, I don't have a market. I haven't done a market survey, and I don't know. That probably doesn't help you a lot, I guess.
That's okay. I can follow up the links if you guys share the slides later.
Yeah, we're going to drop them to the ACE mailing list. Good point. Yeah.
And maybe to add, I know that the plug test has become...
Yeah, I don't know if OMA maintains a list of has a repository of deployed installation. Go ahead.
Oh yeah, I was just going to add that the plug tests have become more and more crowded. So also, I know that there's a plug test that is coming out very soon. So usually there's always, after that, just press release of people who have succeeded the plug test. So I know that there is a few companies out there who have Lightweight M2M server and clients deployed.
The companies attended.
Lightweight M2M thing, Joe.
So I guess not.
Yeah.
Okay. Any other questions?
That's very good.
So if there are no other questions, I think we wrap it up here. I will send the recording around and the slides as well. And if some other questions come to your mind later on, please feel free to drop us a message, and we may be able to have an answer for you, or guide you to some people who may tell you more. Thanks for your participation and for your time.
Thanks a lot, Hannes.
Bye, guys.
Thank you.
Thank you.
Bye. Thanks a lot.
Thank you.